So, hello everyone. Today we have another question that we need to see that says rotate an image. So, you'd be given a square n by n, that is the number of rows and the number of columns have to be equal, and then you have to rotate it by 90 degrees clockwise. You must rotate the matrix. The important parts to consider: you must rotate the matrix in place. Do not allocate another to the matrix and then do the rotation. So just to say, your space complexity has to be bigger of 1. Make sense? Okay. So how is the rotation done? We'll see on a larger scale, that is on 3 by 3. So it's 1, 2, 3, it's 4, 5, 6, it's 7, 8, and 9. And this has to get converted into 7, 4, 1, 8, 5, 2, 9, 6, and 3. Make sense? So what if I tell you from here, we are going to do what? We are going to take the transpose. We are going to take the transpose. If I take the transpose, you can imply many functions of changing it. But I'll go with transpose first. So if I do the transpose, it's like 147, 258, 369. So what's the transpose? Rows become columns and columns become rows. Right? This is what is called your transpose. And what if I see here, it's all done along this. So this gets changed, this gets changed, this gets changed. Right? 159 is your same, if you see that. Do you get that? Now what I have to do? Reverse each row. I hope you get that. Is that understood? So what I have to do is, so basically it's going to be a void function. Rotate image. And we have been passed vector of vector int that calls itself matrix. Okay. So I'll take the rows to be matrix size. And C is equal to R, but I'll just write it that matrix 0 dot size is your columns. While I know that R is equal to C. It is n cross n matrix. Do you get that? Then first step, we talk about step 1 is you can find of another transformations also, right? By which you can reach this. Maybe you can, what if there's a second way to do it. Let's come to the second method. What if I reverse first? If I reverse first, if I reverse the matrix first, then it becomes, okay. If I reverse it column wise, right? The first column, it becomes the first row. If I say this, it becomes 1, 2, 3. Then I'd say it's 4, 5, 6. Then I say it's 7, 8, 9. Okay. And then what do I say? Then I say that transpose it this way. So what it becomes then? 2, 1. 7, 5, 3 stay constant. This is 8 becomes what? 4. 2 your 8 comes here. Then your 9 and 6 come here. So you can do anything, right? This is the second method of solving it. So you can pair in the transformations to get into your final matrix. right? So it's all about what transformations you choose and the order of transformations that you want to imply. So at first, what are we going to do? We're going to transpose the matrix. How do you transpose a matrix? For int I is 0, I less than r, I plus plus. For int j is 0, j less than I, j plus plus. Swap matrix ij with matrix ji. Now why don't I do this entire? Because then it will again come to the same, because I'm this swap, 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 and if the swap goes on, whatever you did from here is again redone, right? It's like you're reversing a big vector, and then you're reversing like first element, last element, reverse. Second first element, second last element, reverse. But what if I say you don't have to stop at n by 2 and you go until n, so whatever you've already reversed will be re-reversed and you will come back to your original array. And that is wrong. Are you getting it? Right. So this is it. And then let's come to your step 2. What is your step 2? Step 2 says reverse each row. How do you do that? You say for int I is 0, I less than r, I plus plus. Are you getting it? So what then you do? You just go in and reverse. How do you reverse it? Then you say reverse matrix I dot begin matrix I dot end. That's it. I hope you don't. And then the time complexity, let's talk about it. So when you talk about time complexity, it comes out to be big O of n square. And if I talk about the space complexity, it is big O of 1. Should you have any doubts, please let me know in the comment section. I'll be most happy to take your doubts, right? Be there any concerns, be there any doubts that you want me to take them up, just go in, write up in the comment section and I'll make sure I'm looking into them, right? Thank you so much. Bye-bye.